Hello, I'm Landon Schlungen, and today we're going to go through the intermediate algorithm scripting challenges. Last time we left off with Pig Latin, and that's where we're going to pick up today. So for this challenge, we have to change the words that are passed into it, and we have to change it into a different word, but it's like Pig Latin. So basically the rules of Pig Latin are, if it begins with a consonant, take the consonant or consonant cluster, move it to the end of the word and add AY to it. If a word begins with a vowel, just add way at the end. So to start this one off, I'm going to start by splitting the string. So let string array equal string.split at every character. And then I'm also just going to check if it starts with a vowel at the start, then add way at the end so that we get that rule out of the way. So if, and I'm going to use a regular expression of A, E, I or U, insensitive case dot test, and we're going to test it on the first character in the string. And then if that's true, then we want to add way at the end. So then we just do return string plus way, and that should work for that. I'm going to console log this as well, make sure that part's working. So if it starts with an O, then it'll just add way at the end. Now to do this rule, we have to use a for loop. So I'll do a for loop here, do for, let I equal 0, I less than string.length, I plus plus, and then I'm going to do if, and then I'm going to do the same test basically. So I'm going to check if it's an A, E, I, or U. So if this was a C, then it would stop at the O, and this would be true if I make this an I. And what do I want to do? If that's true, I want to split this string up into a start and an end so that I can switch the places of the substrings. So I think what I'm going to do here is have some variables of start and end. Start equals an empty string and end equals an empty string to start. And then I'm also going to have a full that equals an empty array at the start. So we're going to do let start equal the string dot split, or the string array, because it has to be on an array, or dot slice. And where do we want to slice it? We want to slice it at I. We want to go from 0 to I to get the start, and then to get the end, we just want to do I to the end. And then we want to have full equal to an array of the end, because we want the end to be first, and we want this start to be last. And then we also want to add an AY at the end. And then we also want to break out of the loop, since it only happens once it hits the first vowel, and we won't do it again if it hits like a second vowel. Then we'll just break out of the loop once it hits the first one. So then once we're broken out of the loop, we also want to check if there's no vowels. So I'll make a variable of no vowels, and I'll equal it to true at the start. But then let's say it does pass this test, then we want to set it to false. So let no vowels equal to false. So basically, if this never passes, then it means there's no vowels in the string, and we want to just return the string plus equals AY instead of WAY, just AY. And yeah, that should work. It's working for that one, and it should work for these ones as well. I'll try Schwartz. So yeah, there's Schwartz A. That is not it. Oh, because I have to return full. Oh, and also this let shouldn't be here. I should return full dot join. And there should not be a let here as well. And here and here. I don't know why I did that. There we go. Archway. Same thing as what's right here, and it should work. So let's do it. Cool. Search and replace. For this challenge, we want to find the second argument in this first string, and we want to replace it with the second or the third argument, which would be mall. So we want this to return let us go to the mall instead of let us go to the store. But then we also want to keep the case that this first thing has. So if this is uppercase, then we also want sitting to be uppercase, even though this is lowercase right here. Otherwise it'd be super easy. We would just do string.replace, and then we just do before and after. And let me console log this quick. So yeah, there it says a quick brown fox leaped over the lazy dog instead of jumped, but it doesn't handle the cases where this is uppercase, so we have to do that a different way. And the way we will handle that is by finding the index of this word by doing let index equal string.index of before. So that finds the index of jumped in here, and then we want to see if it's uppercase or not. So if string index equals string index but to uppercase. Then we want our after to equal after.char at 0, which will get the first character of after, which in this case is the L. And then we want to concatenate that with after.slice of 1. So that'll get all of these ones. So if it's uppercase, we also want this to be uppercase. So to uppercase. And then else, we want to do the same thing except have it be lowercase. So instead of 2 uppercase, we'll do 2 lowercase. And so now if we make this uppercase and this uppercase, we see that leaped is uppercase, even though this is lowercase here. So char at 0 gets this first letter and turns it to uppercase if this word is uppercase. And then we just do string.replace on it, our before, and then our after it's been changed, and then we return it, and it should work. Yep, cool. DNA pairing. For this challenge, we want to, given an input of GCG, we want to return its pairs, which is GC, CG, GC. We can brute force this one just with for loop and if statements. So I think that's what I'm going to do. We're going to first split up our string. We're going to do let array equal string.split and then make a for loop. We actually don't even have to split it up because string.length, it will do it for us. And in this for loop, we want to do if string of I equals a G, then we want to do answer.push an array of G and C. Pretty simple. And then we can have our answer up here of an empty array at the start, and then we can do a bunch of else ifs here. So there we have a bunch of else ifs, and we just have to change these letters here. So if it's a C, then we'll do CG. If it is a T, then we'll do TA. Else, it means it is a, so we want to do answer.push the A and the T after. And then we can return answer at the end. Let's console log this. So yeah, that's the right answer. GC, CG, GC, just like it shows up here. And these ones shouldn't even have a problem at all either. So yeah, this one was pretty simple. And I hope you can follow along because yeah, just brute force. Let's try it. Yep. All right, missing letters. For this challenge, we want to find the letter that's missing from this string. Thankfully, it's already in alphabetical order for all of them. So in this case, A, B, C, E, D is missing from this because the alphabet goes A, B, C, D, E, F, G, H. So to do this one, we're going to start with having a variable called alphabet, and that's going to equal A, B, C, D all the way to the end. So yeah, there's our alphabet, the English alphabet. And then what we want to do is we want to find our start in this alphabet and our end in this alphabet. So to do that, we're going to have our let start equal alphabet.index of our first character in the string. So a string of 0. So in this case, it would be 0 because A is at the start, and index of returns that index of where it is. And then we're going to have let end equal alphabet.index of, except this time we want to grab the E, which is at the end. And the way we do that was we grab our string, and then we grab our string.length minus 1. In this case, string.length is 4, minus 1 is 3, so it grabs the third index, which is E. And then that will grab E from here, which would be an index of 4. So end will equal 4, start will equal 0. And now we want to use our for loop here. For let I equal the start, we want I less than the end, less than or equal to, I think, and then I++ to loop through. And then we will just want to check if alphabet of I does not equal our string of J. We don't have J yet, so I'll make let J equal 0. And we just want to increment J every time in this for loop, so we'll just do J++ in here. If that's true, if they're not equal, then we just want to return that letter. So return alphabet of I. And then otherwise we want to return undefined, like this one. If they're all in there, then just return undefined. So let's console log this here, and sweet, we get a D, and because it's not in there. If we have FG in here, FGH, and then we add a D, and then let's say we have F missing, then it'll return F. So that should work. Sweet, let's just do it. Cool. Sorted union. For this challenge, we want to keep the original order of all these numbers, but then get rid of all the duplicates. So in this case, there's 1, 3, 2, 5, 2, 1, 4, and 2, 1 in this argument list. So we want to just return the unique values in the order that they were placed in this argument list. So to get this argument list, we have to do dot 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 args here, and that'll give us an array of all the arguments. If I just show you here. So yeah, there's our array of all of these. And I don't think it's necessary to have all of these arrays like separate. So what I want to do is actually flatten it out. And the way we do that is we have our flat array equal to our args dot flat. And that's a JavaScript function that'll just make it flat. So if I console log this flat array, you can see it gets rid of these extra brackets in here and just makes it one array with all the numbers in it. So that's awesome. And now that we have that, we can actually do a for each on it. So flat array dot for each. So this is our for loop basically, and we want to do for each number. What do we want to do? We want to check if this number has already been stated before. Then we want to get rid of it basically. So we're going to have our answer up here, and it's going to be an array. It's going to always start with the first one because that one's always going to be unique. So we can just do flat array of 0. So that'll be the first one, which would be 1. And then we want to check if answer dot index of the number does not equal 0, which means that it is not in it, or it does not equal -1. So that means that it's not in the answer array already. If it's not in the answer array already, then we want to push it on. Then we'll push on the number, and then we'll return answer at the end. And I'll console log this. Okay, so that is not right. We're getting 1, 1, 1, 1. Oh, we want to do equal, equal. Yeah, because that means it's not in it. And there we're getting 1, 3, 2, 5, and 4, which is the same as this, which is perfect. So I kind of like this solution. First we flatten the array out, and then we can do a for each on it. And then we check if that number is in the answer array already. And if it is, then we skip it. But if it's not in that answer array already, then we push it on, and then we return it. So let's do it. Sweet. Convert HTML entities. For this challenge, we want to take the weird signs of ampersand, less than, greater than, double quote, and apostrophe, and we want to turn it into the way we can express it in HTML. Because if we had, okay, let's say we have an H1 tag, right? And we have our less than sign in here. It's not going to know what to do with that. So what we actually have to do is we have to do ampersand less than and then semicolon, and that'll actually turn it into the less than sign. So that's why this is actually kind of useful. But there is kind of a way to just brute force this, and we can just do like string.replace a bunch of times. So we'll start with our ampersand. So we'll go let amp string equal to string.replace, and we want to replace our ampersand. So we'll do a regular expression to find all the ampersands globally, and we want to replace it with our ampersand, and what is it? It's amp semicolon, amp semicolon. There we go. So that'll do it for this one. Now we just have to do it for the rest of these. So I'll just copy this down a couple times and change this to less than string, change this to the less than symbol, change this to ampersand less than, and we also want to have this be on amp string, and then we can change this to greater than here as well, and change this to less than string. So just continue this pattern down until we complete them all. Okay, so there we have our ampersand, our less than, our greater than, our quotes, and our apostrophe, and then we just want to return a string at the end, and that should work. Should work for all of them. A string. There we go. Let's try this test here. So this basically has all of them in it, and it is returning the correct thing. It's turning the apostrophe into ampersand apos. It's turning ampersand into ampersand amp, turning less than into ampersand less than, and same for the other ones. So let's try it. Cool. Sum all of the odd Fibonacci numbers. For this challenge, we want to add up all of the odd Fibonacci numbers up to a certain point. So the Fibonacci sequence goes like this: 1, 1, 2, 3, 5, 8, 13, 21. It adds up the two numbers that come before it. So in this case, 1 and 1 equals 2, then 2 plus 1 equals 3, 3 plus 2 equals 5. 5 plus 3 equals 8, and so on. And then for this challenge, we want to add up all the odd ones. So up to 10, it would be 1, 1, 3, and 5, and it would be 10 as an answer. So to do this one, we have to use a for loop. We have to know like our first number and our second number, and then add them together. So let's get started here. We're gonna have our first number, let first equal to 1 and second equal to 1. And then we're gonna have our sequence as an array, and it's going to start with 1 in it already. And then we are going to do a while loop here. Of while our second is less than or equal to our number that's passed in. Then we want to have a temp variable equal to first, our first equal to second, and our second equal to temp plus second. And then we want to do sequence.push our first number. So this will give us our Fibonacci sequence. So if I just console log our sequence, it goes all the way up to that number. So if I have this as 100, then it'll do the Fibonacci sequence up to 100. So that's cool. The way it does it is by grabbing our first number, having temp equal to 1, and then first equals 1 because second equals 1, and then second now equals 2, and then we push 1 on, so that's this one. But now second equals 2, temp still equals 1, but now first will equal 2, and now we do 1 plus 2, so now second equals 3, and we push 2 on. So there's the 2 here. But now second equals 3, temp equals first, and first we set to 2 last time, so now temp equals 2, and then we will do 2 plus 3, which is 5, and we'll push on 3. So yeah, it just goes through that until it hits up to 100. There's a lot of algorithm challenges that use the Fibonacci sequence, so it's a good thing to know like how to do this. There's another way to do it with recursion that might be easier, but this way is pretty cool too. So yeah, now that we have our sequence, we can do a reduce on it to find the sum of all the odd numbers. So we'll do sequence.reduce, and we'll reduce each number. And first we'll check if number is an odd number, so we'll do modulus of 2 equals 1. So that'll check if it's odd. If it's odd, we want to, it also takes an accumulator. So the accumulator is this first one. Its first argument is the accumulator, and then the second argument is the actual number. Then we want our accumulator to be plus the number. Otherwise, we want the accumulator to plus 0. And then we want the accumulator to start at 0, which is the second argument in the reduce function. So now we just need to set a variable to this. So let answer equal this, and let's console log answer quick. So in this case, 100 will give 188. If we have 10 here, then it should return 10. Yep. If we have, let's say 1,000, it should be 1,785, which is right. So that's cool. And we just have to return answer here and then try it out. Let's do it. Cool. Sum all primes. For this challenge, we want to return the sum of all prime numbers that are less than or equal to num. So a prime number is a number that is only divisible by itself and 1. And basically, the biggest challenge of this challenge is finding all the prime numbers. So how do we actually go about finding a prime number? Well, I think we're going to have a function outside of this, first of all, that takes a number, and it returns true or false based on if it's prime. So I forgot to name it here. I'll do is prime. So it'll return true if it is a prime and false otherwise. And to find this out, we will use a for loop of let I equal to 2 at the start, I less than x, I plus plus. And we're going to check if x modulus I equal to 0. Then we want to return false from this. Otherwise, if it goes through the whole for loop without finding a number that divides into it, then we want to return true if x is not equal to a 1 or x is not equal to a 0. So basically, if x isn't 1 or 0, then return true is what this is saying. So basically, if let's say 10 is passed into this, it'll check, this should be x here actually, or all of the x should be nums. So yeah, let's say the number is 10, then we'll start at 2 and we'll check if 10 modulus 2 is equal to 0. In this case, that is true. So it'll just return false right away. It won't even check farther. Let's say it's 11, which is a prime number. Then it'll check if 2 is divisible by it. Then it'll check 3, then 4, then 5, then 6, all the way up to 10. And in this case, it would not find any that are divisible. So then it'll return true because it's not a 1 or a 0. So then inside of this main function here, we want to have our sum variable equal to 0, and then have a for loop of let I equal 0, I less than num, I plus plus. We'll go if is prime, our number, or our I. So if I is prime, then we want to do sum plus equals of I, and then return sum at the end. Let's try console logging this, and it should return 17. Yep, cool. And if we have 977 here, then it is a little bit off, and I think that's because we have to do I less than or equal to number, just in case this number right here is prime. So yeah, now it works. Yeah, let's just move on here. Cool. Smallest common multiple. For this challenge, we want to find the smallest common multiple of all the numbers, including these two numbers that are in between. So we want to find the smallest common multiple of 1, 2, 3, 4, and 5, which would be 60. Because 1, 2, 3, 4, and 5 can all go into 60. Basically, 60 is divisible by all of those numbers. So that's what a smallest common multiple is. The way we can do this one is actually really clever. First, we want to find the max and the min, because these can be in any order. So the way we can do that is let max equal math.max. We can do math.max on our array. We'll just spread it in there. and it'll grab the maximum number out of this array, which in this case is 5. And we want to do the same thing for min, so we can just do math.min and change the max to min here as well. And then at the start we'll have our solution equal to max, and then we want to do a for loop, let I equal max minus 1. So in this case it would be 4 at the start, and then I greater than or equal to min I minus minus. So this is a backwards for loop. It starts at 4 and then goes down to 1 in this case. And then we want to say if the solution modulus I, so if solution modulus I equals 0 or doesn't equal 0, if it doesn't equal 0, which means that something is divisible in it, then we want to increment our solution by our max, and then we want to set I equal to max. So basically restart is what this line is saying. Restart the loop if this is ever true, and then we can return our solution, and that's all it is. The way they did this is really clever. I had to use a hint for this one. So yeah, that gives us our right answer of 60. If I do 2 and 10 here, then it gives us 2,520, which is right. So yeah, let's just go through this again because I was a little confused at first as well. So max is 4 here, or I mean I equals 4, and we're checking if 5 is divisible by 4, which it's not. So then we'll take solution and we'll increment it by 5. So now solution equals 10, and we want to reset our for loop. So now I is back to 5, or in this case it's 10. I'll do 5 and 1 again. Then it will be back to 5. But now the difference is solution equals 10. So now we'll check solution divisible by 4 again, which isn't true, and then it'll go to 15 and then to 20. In the case of 20, then it is divisible by 4, so it doesn't do this block of code at all, and it checks 3 next because now I equals 3. Is 20 divisible by 3? It's actually not, so then we want to increment it by 5 again and restart. And it goes all the way up to 60. In the case of 60, 60 is divisible by 4 and 3 and 2 and of course 1. And if it gets through this for loop without any like restarts or anything, then it'll just return the solution. So that's how we get 60 here. Hopefully I explained that well enough, and let's move on. Drop it. This challenge we want to return an array of the elements after this function passes. So basically if n is greater than or equal to 3, so one of these numbers, if it's greater than or equal to 3, then we want to return the array after that. So in this case it would be 3 and 4. This last one here, n greater than or equal to 2, so in that case 3 would hit that, and then we want to return everything after it, so 3, 9, and 2 in this case. So that's this one is really easy. I guess the only thing confusing about it is that a function is passed as a parameter. So we'll have our answer equal to an empty array to start, and then we'll do a for loop of let I equal 0, I less than array.length, I plus plus, to loop through these elements here, and then if our function of array I, so we're passing this number into this function and we're checking if it passes this. If that's true, then we just want to set our answer equal to array.slice I, so everything after I, and then we want to break out of this for loop and don't want to do anything after, and then we just want to return our answer. And that works. And just to show, I'll console log it. So yep, the first number is less than 3, so then it returns all of them. Let's do this last one of 9 and 2 here, and then n greater than 2. So yeah, that'll give us 3, 9, and 2, which is right. And yeah, this one was pretty easy overall. Let's just do it. Cool. And I think this is where I'm going to stop for part 2. We'll continue on with these intermediate algorithm scripting challenges in my next video, and it will start off with Steamroller in that one. I definitely came more prepared for this video, like I did them beforehand and then did them again and tried to explain them better, so I didn't struggle as much, but I definitely used some hints in some of them. But yeah, hopefully you learned something. I definitely learned some stuff, and thanks for watching, and I'll see you in the next video. Bye.